Good evening, everyone. My name is Aaron Liskey, and I am doing my project on using multiple computers in a cluster to help crack passwords. So what I did was I built a Raspberry Pi cluster, which are tiny computers about the size of a deck of cards. Each one of mine has 1.5 gigahertz quad core processor, 4 gigs of RAM, onboard gigabit Ethernet. I built this with a small gigabit switch to tie it in with my home network because I still need to manage these things. I used a 12-volt power supply. I had issues with my first one. It kind of fried it, and then it took one of the pies with it. So I had to get a new one. Anyway, and they're all running Ubuntu Server version 2004.3, which is right now their LTS version. So I wrote the software to do this. There were two parts to it. One is a controller part. The controller part dictates what the nodes, which is what I'm calling each Raspberry Pi. The controller gives out the work to the nodes to do, and it receives it back. So the controller, it picks the password from the list. I use the rocku.txt word list from Kali because it was probably the most comprehensive and the largest one because I wanted to run this continuously and see how it would do over time. So it sends out the password to be cracked, and it receives the work back from the nodes or the completed hash. So the nodes are doing all the processing, and all that the controller is doing is sending out plain text passwords and bringing it back, and then comparing it against the known hash. I chose a password that was like 42 characters long because I didn't want it to find the password. I guess I could have just written that part out of the software, but I didn't want it to find the password so that I could run this over time, see how many hashes could be done, and get data on how quickly those were being done from the nodes that I was using. So the nodes, all they do is receive the password from the controller. It actually does the hashing. I use bcrypt with 12 um, iterations, and then it sends the hash back to controller. I use Java to write this. Java is my primary programming language, so I felt most comfortable doing it with that, and I could get it done quicker. The Raspberry Pis are running the Open Java Development Kit runtime environment, and I did have an issue where the controller, it was receiving too many things back from the nodes simultaneously, and because of that, the port that I was using was being blocked because I was using TCP instead of UDP. So it was creating a connection with each node. I was originally going to use MPI, the message processing interface. However, that I was having way too many issues with that, and I could achieve the same thing much faster using standard TCP connections. So to overcome this issue, I just created a multi-threaded piece of software so that it could return the hashes back on multiple different ports simultaneously and create a non-blocking environment. So my original project plan was to use the message passing interface, which is meant for cluster computing. However, with this small scale project and the time constraints, I wasn't able to overcome some of the issues that I was having with it. And I honestly do not think that it would have changed the overall outcome of the project because I don't have hundreds or thousands of nodes. I was only running with 3 or 4. Actually, in the end, I was only running with 3 because of more hardware issues. Um, so I overcame the software issues by kind of switching gears with the libraries that I was using. I went with a traditional TCP, which, like I said, it didn't really change the outcome at all. Um, so I don't want to show that yet. So this is the software that is running right now. I have the 3 nodes, which are the yellow terminals. Those are on the Ubuntu Raspberry Pis. All they're doing is taking in the plain text password and creating the hash for it, and then sending the hash back to the Windows terminal, which is actually running on my desktop. And all that does is checks the password. If it matches, then it stops everything. If it doesn't match, it just keeps going and just logs the timestamp of when the hash was received, because I really wanted to see how fast this was functioning. So getting the time that each hash was being returned was paramount to this. Otherwise, I wouldn't have any idea of how many were done, how long it was taking each of them, or really any valuable information. So back to this, like I said, it doesn't take advantage of full cluster computing, but it does split the workload amongst multiple machines. And with as many as I was using and how it was done, it doesn't appear that there was any sort of diminishing return, like with a lot of cluster computing applications. This may change if there were hundreds or thousands of nodes, but in this limited environment, I wasn't able to find anything. So the return delta time, or the time between when hashes were returned, sometimes hashes were returned with 0 milliseconds between the two, where they came from two separate machines at almost identical time. The maximum time between them was 726 milliseconds, so about 3/4 of a second. And that appeared to really be an outlier because the median was 58 milliseconds with an overall average of 65.59. So on average, not it's it's not taking it's literally about 3 times as fast as if a single node was running with um, very small margin of error. I think it was like 0.03% margin of error um, with that. And I had this running for about 86 continuous hours without an issue. My log file got to be about 320 megs and about 3 million lines. However, I realized that I was actually logging not only the password that was being sent out, but the hash that was being returned. So I was inadvertently creating a rainbow table in my log file, and that's not the desired approach to this, because if you're cracking a password this way, you're trying to avoid using a rainbow table because of that time memory trade-off. Because what takes more time uses less memory, but what takes more memory uses less time. And at this point, I was kind of doing both. So that is my project as it stands. I do kind of want to continue working on this because I want to actually look at the bcrypt hashing algorithm and see if I can actually split that up between the nodes so that a single hash goes out to all of them and they all split up the work. But I think that's going to require a lot more software development on my end. So that's what I have, and thank you for watching.